Dear students, welcome back to this session. As I had told in the last session that we will be taking the problems of the frames. We are going to first concentrate on the frames which will have no lateral movement of the joints, that is open frames like T frames or portal frames without lateral movement of the joints. We'll solve them and see how to draw bending moment diagram and shear force diagram. So I have taken a problem here. You can see this is the frame. This is a T frame. It has three members A, B, B, C and C, D, and the loads are shown as on the board. You can see 20 kN per meter for AB, it is UDL. There is a concentrated load of 40 kN and a distance of 2 meters from B for BC, and there is a vertical member here. A vertical member which is subjected to a load of 30 kN at the center of BD. So analyze this frame using slope deflection method. So first this is the frame of the first category, that is frame without lateral movement of the joint. So only primary unknowns are rotations. So the primary unknowns are only rotations. How many rotations are there? There are 1, 2, 3, 4 supports. But out of 4 supports, 2 supports are fixed. 2 supports are not fixed. So they undergo rotation. So the primary unknowns are theta B and theta C. Now let us write down how to analyze this frame, like how we had analyzed the beams. First find out the fixed at moments, then write down the slope deflection equations, then formulate the joint equilibrium conditions, solve them and get the unknowns theta B, theta C and substitute them in the slope deflection equations and get the moments, and using the moments draw BMT and SMT. That is the flow. So we are going to do the same thing here. So first is fixed at moments. How many members are there? There are 3 members. So 6 fixed at moment I am going to write. First is MFDD. MFDD is equal to plus W L square divided by 12. 4 square divided by 12. It is 26.667. MFDA minus W L square divided by 12. That is minus 26.667. Then MFBC plus WA square upon L square plus W for BC A 2 B square upon L square WA B square upon L square, that is MFBC is equal to 8.889 and MFC is equal to minus WB A square upon 3 square, that is minus 17.77. And then for BD, MFDB is equal to, see, for DB the load is acting from left to right, so you have to have your vision from right to left. So when you have the vision, this becomes left hand, this becomes right hand. So left hand anti-clockwise here, and that is why here it is MFDB is equal to, this is anti-clockwise, this is clockwise. So anti-clockwise because both are hogging. MFDB will be equal to plus W L by W is 30, L is 4 divided by 8. This is 15. And MFBD will be equal to minus 30 into 4 divided by 8. This is minus 30. All are in kilometer meter only. This is kilometer meter. This also is in kilometer meter. Now once again I will explain why the moments are why MFDB is positive and MFBD is negative. You have to have your vision because the load is acting from, you can see you have to have your vision in the direction opposite to the load. You can see here the load is acting from top to bottom, your vision is like this. This becomes left hand, this becomes right hand. So now similarly the load is acting from left to right, your vision is in the opposite direction to the load, that is your direction of vision is like this. So this becomes left hand and this becomes right hand. So for left hand anti-clockwise, you can see here for left hand anti-clockwise. So anti-clockwise is positive, and that is why MFDB is plus 30 into 4 by 8 and MFBD is clockwise minus 30 into 4 by 8, that is minus 15. So these are the fixed end moments. Once we write the fixed end moments, now we have to write the 6 slope deflection equations. Now let us write down the slope deflection equation. How many? 6. We can see MDB is equal to MFDB. MFDB is 26.667 plus 2E. I is I. N is 4. Minus 2 theta A 0 because theta A is 0 minus theta B. This is your equation 1. This is MDB. MDA. MFDA minus 26.667 plus 2E, I is I, N is 4, minus 2 theta B, minus theta is 0. So this is the second equation. And similarly MBC, MFBC we already know 8.889 plus 2E, I is I, L is 3, minus 2 theta B, minus theta C. This is the third equation. MFCB minus 17.77 plus 2E, I is I, N is 3, minus 2 theta C, minus theta D, reverse. This is your fourth equation. Then the remaining two, MFDB is equal to 15. Plus 2E, I is I, L for dB is 4, minus 2 theta D, 0, minus theta D. This is your fifth equation. And the last one, MFBD is MFBD minus 15, plus 2E, I is I, L is 4, minus 2 theta B, minus theta D, 0. So this is the sixth equation. That means all the 6 equations I have written. Once again, I will come back to this problem. Don't lose the focus. This is the new problem. This is the frame, and you are supposed to analyze using slope deflection method. The primary unknowns are theta B and theta C. First, what we have done? We have written the fixed end moments. How many fixed end moments? 6. MFAD, MFDA, MFBC, MFCB, MFDB, MFBD. MFDB and MFBD, the signs, MFDB is positive, MFBD is negative because you have to have vision in the opposite direction to the loop. So after writing the fixed end moments, then you have to write 6 slope deflection equations. That is what I have written. There is nothing new here. MFAB plus 2B upon L minus 2 theta A minus theta B. Theta A is 0. So theta B only exists. Similarly MD. Then similarly MPC. Theta B, theta C both exist here. MCB. And then MDB, theta D is 0, theta B only exists. MBD, theta B exists, theta D is equal to 0. That means all the 6 equations I have written. And when we write 6 equations, you will understand that all the 6 equations contain how many unknowns? Look at all these 6 equations. They contain theta B and theta C. Or if you take an EI inside, the unknowns will be EI theta B and EI theta C. Now what you have to do? You have to formulate 2 conditions because the unknowns are 2. Which are those 2 unknowns? EI theta B, EI theta C. Formulate 2 conditions. Where are the 2 conditions? Now I am going to write the 2 conditions which are popularly known as what? Joint equilibrium conditions. Joint equilibrium conditions. How many we need? We need 2 conditions because there are 2 unknowns, theta B and theta C, or EI theta B and EI theta C. So what is the first condition? That is at B. Sum of all the moments meeting at B should be 0. That is algebraic sum of all the moments meeting at B equal to 0. How many moments are meeting at B? We can see there are 3 members meeting, so there will be 3 moments. MBA plus MBC plus MBD equal to 0. So my first condition is MBA plus MBC plus MBD equal to 0. 3, because 3 members are working here, 3 moments are there at B. MBA plus MBC plus MBD equal to 0. So this is my first condition, first normal condition. Where is the second condition? It is at C. It is hinged end, so moment, and there is no overhead, so moment at C equal to 0. That means the second condition is MCB equal to 0. My second condition. So these are the two conditions. The first condition, MBA plus MBC plus MBD equal to 0. Second condition is MCB equal to 0. And you have to simplify these conditions. You have to simplify the first Roman condition, second Roman condition. When you simplify, you are going to get two simultaneous equations in terms of EI theta B and EI theta C. Solve them. You are going to get EI theta B, EI theta C. Once you know EI theta B, EI theta C, what you need to do? You have to substitute them back in all the 6 slope deflection equations and get the slope deflection and get the moments. Get the moments for all the members MBB, MBA, MBC, MCD, MBD, MDB. When you get the moments, you should apply the check. What is the check? We have substituted the condition MBA plus MBC plus MBD equal to 0. The same condition should come. That means if you add algebra in the name after finding the moments, MBA plus MBC plus MBD should be 0. And MCB also should be equal to 0. That is what we have done here. So I will leave this part to you, and when we meet in the next class or next session, we will continue this problem and we'll find out the moments. I hope you can do it, and I will leave this small bit of work to you. Analyze these two or simplify these two and get the moments and try to draw bending moment diagram. I am going to do it in the next session anyhow, but I want you to try and get the bending moment diagram. I hope this is very simple and very straightforward question. There is no difference in the analysis of frames of this nature and in the analysis of beams, because the primary unknowns are only the rotations EI theta B, EI theta C. So I hope you have understood this. Let me pause here. Thank you.